Oh, and we're going to be doing a recap of all the trigonometry that we've done so far. All right, so I've put some practice questions on the screen, and we're going to go quickly through what it is that we learned about trigonometry, starting with this question over here. So the question over here has our theta missing over here. So it says, the question is, calculate for theta. Now, if any of you are new, I want you to follow with what we're doing here so that you guys don't get confused. But if you are a veteran Watobian and you'd like to help us with this question, please put your hand up. I would love to have a conversation with either one of you, just so we can show the newbies how it's done, and you guys can, then we can take it from there. If not, you can go ahead and calculate it. If you're not feeling confident about unmuting and speaking to me, you can go ahead and calculate it and then pop your answer in the chat for me when you're ready. Okay, I'm going to give everybody about 2 minutes. If anybody wants to go ahead and do this with me, remember you're going to need your calculators. We are doing trig, so you do need your calculator. But I would like you guys to calculate for that for me. Okay, now remember, in relation to my angle where everything is sitting, okay, if this is my angle over here, this side right next door to my angle is called something, and the one all the way on the other side is also called something. Okay, pop your answer in the chat when you're ready, guys. Oh, I forgot our mnemonic device. I need to write it down. Okay. I need to write down in big, bold letters over here. So, car, tower. Okay, and then you need to remember which one of these we're going to use for our question. Okay. Oratile says, isn't it Pythag? Well, we could use Pythag, but Oratile, all that would do is it would give me this side. And I don't want this side. That's not the side that I want. Pythagoras, remember, we use when we're looking for sides. Now I'm looking for an angle. And can anyone remind us in the chat, whenever we're looking for an angle, what are we going to click on our calculators? Hello, Google. What do we click on our calculators? Anybody remember? I'm looking for an angle. That's it, Funzo. Therefore, I shift angle. I shift angle. Don't forget. We shift angle. Okay. Yes, that's it, Jonathan. Jonathan, you're 100% on the money. I hope you use the correct things to get there. You also forgot 45 watt, Jonathan. 45 watt. Don't forget. Hi, Funzo. That's it. Thank you. You know, I'm very pedantic about that. Hi, Funzo. No, Funzo, you need to unmute for me, my sweetie. Hello, Anele.
Hi, ma'am.
Hello, there we go. Hi, how are you?
I'm fine, and you?
I'm excellent. Thank you so much. All right, are you going to help us out with this question, or do you have a question yourself?
I was asking if I could answer the question.
Oh, excellent. All right, I'm going to ask you a series of questions, and you need to remember to give me all the information, right? Okay, so this side, here's my angle over here. What is this side right next to my angle called?
Adjacent.
Excellent. This is my adjacent side. And what about the side all the way over here?
That's the opposite.
Good. This is the opposite side. All right, so Punzo, between saw and car and tower, which one are we using?
Tower, which is 10.
Good, it's tower, which is 10. So I have my adjacent side and I have my opposite side. And what am I looking for? What do I want? I want my?
Our angle.
Good, we're looking for our angle. So if we're looking for our angle, what are we going to click on our calculator?
Shift.
Good, we're going to click shift. Good, we're going to click shift. All right, so if we use tan, I want you to tell me, what am I going to write?
So we're going to say 10 theta is equal to 3 divided by 3.
Good, 3 over 3. My opposite, which is 3, over my adjacent, which is 3. All right, what's my next step? Remember, I'm looking for my angle.
10 theta is equal to 45 degrees.
Good. All right. We skipped one step. We skipped one step over there. Okay, remember we need to go theta is equal to arctan or shift tan, right, of 3/3. Okay, don't forget this part, so it's very, very important. Okay, then we can go, therefore, theta is equal to
45 degrees.
Excellent. It's equal to 45 degrees. C. Excellent. All right. Don't forget, this part is also very important. Okay. But you did that so beautifully. Thank you, Funzo, for always, always, always being willing to help out. Thank you very much, my sweetie. Excellent stuff. Very well done. All right. Okay. I hope you guys all see what's happened here with the order in which we do things. Now, remember, every time we're looking for an angle, every time we look for an angle, we always need to shift angle. Okay. We always need to click shift. All right, let's look at the next question. Remember, guys, this is all a recap. If you're not 100% with what's happening on the screen right now, we have many, many videos that we've just done on trigonometry that tackle these kinds of questions. Okay, so I hope that you guys are getting the idea of how to do these questions and what is considered or what is expected of you. All right, so here's our next challenge. We're looking for x. Calculate for x. Okay, we're calculating for this x over here. Now, what we need to ask ourselves is, what do we have? Okay, and what do we want? And then we need to look at that in relation to our mnemonic device, in relation to saw, car, tower. All right, tell me in the chat, everyone. What do we have? What does our drawing give us? Tell me, what has our drawing given us that we can use to solve for this question? Tell me in the chat, everyone. Remember, this side is going to be called something. This side over here, this long side is going to be called something. Okay. Anybody got any idea? Good. Oratile says we have a 45 degrees. Yes, which means we have an angle, right? We've got 45 degrees, which is an angle. And what else do we have? Funzo says, we don't quite have the adjacent. We don't have the adjacent. What do we have? I agree with you. Yes, Jonathan, we have the hypotenuse. Good. We've got the hypotenuse. And what are we looking for? What do we want? What is it that we want? We want, Funzo, you had it correct. Which side is it, Colorado? Our x is the good, Mlando, that's it. That is our adjacent side. Good, it's our adjacent side. So we need to think, guys, between saw, car, and tower. Which one of them uses adjacent and hypotenuse? The saw, the car, or the tower? Which one of them? That's it, Michael. Good, the car of it. Okay, or the cos, because the C in car stands for cos. So we're going to go cos of theta is equal to adjacent over hypotenuse. That's the information we have. Now, have they given us our angle? Yes, they have. They've told us that our angle is 45 degrees. So what we're going to do is we're going to go cos of 45 degrees is equal to our adjacent, which is now named x, over our hypotenuse, which is 17. Now, how do I get rid of this divide by 17, guys? If I've got to divide by 17, because remember, I'm trying to isolate x. How do I get rid of the divide by 17? Oh, Funzo, you are on fire today. That's 100% correct. If I've got divide by 17, I need to do the inverse operation, which would be to multiply by 17. And whatever I do on the right-hand side, I need to make sure I do that on the left-hand side as well. Multiply by 17. So 17 divided by 17 will give us nothing. So what I will actually need to punch into my calculator, x is equal to 17 times cos of 45 degrees. And you guys are going to do that for me now. Punch that into your calculator for me and tell me, what is 17 cos 45? And if you get a funky answer that doesn't look like everybody else's, make sure your calculator is in degrees. Okay, make sure that your calculator is in degrees, guys. Okay, you guys, You guys can give me the decimal. So I want you guys to click SD for me. You don't have to leave it in third form because it looks a little bit ugly in third form. But let's do two decimals after the comma. Tell me, what do we get? Jonathan, I'm not sure how you could get 17. I agree with Lihle and Muhammad. I hope I said that correctly. Oh, it's Muhammad. Hi, Tahir. Okay, I see you, Muhammad. Okay, I'll say that properly next time. Ah, Jonathan. Oh no, not 10. Cos, that's it. Good. So cos is going to give us 12,02. All right. Do I need to write degrees? Should I write 12,02 degrees? Yes or no? Ooh, I see people saying yes, ma'am. But are we calculating for an angle or are we calculating for a side? Which one are we calculating for? We're calculating for a side, so it can't be in degrees. We can write units, sure. Okay, Anele, okay, you need to go on your calculator and click Shift, and then there's a button that says Mode, and then look for something that says DEG. Look for a button that says DEG. On my calculator, in front of the DEG, there's a 3. So click Shift, and then Mode, and then click on the button. You'll see it's got GED, and in front of GED, there's a button, there's a number. Whatever number that is, click this number. Okay, click that number, and that will put your calculator in degrees for you. Okay, I hope that helped. Excellent. All right. Okay, cool. All right, so we're going to actually be talking about elevation and depression, or angles of elevation and depression. We have done a couple of these before. I just think we didn't do too many of them, and it wasn't so fun for us because we didn't quite get into it. But I want us to get used to interpreting questions. Most of your exam papers, especially in grade 10, will give you some sort of drawing that kind of explains what's happening. But we're going to try and do it without having the drawing, and we're going to try and interpret what's happening. Now, we're going to do a quick reminder of what angles of elevation and depression are. Okay, so if I'm sitting all the way down here, I'm going to draw myself looking all nice, wearing a tiny little skirt, and I also like having funky hair. There we go. Okay, that's me. That's me. That's Teacher Coco. Hi. Okay, that's me over there. Now, if I'm sitting all the way over here and I'm putting up a flagpole, I want a string that puts together a flagpole, and my flagpole is sitting over here. Here's my flagpole. Thank you, Funzo. I'm going to dye my hair purple. I love it. All right. Okay, if my flagpole is 10 meters tall, right, I want to know how much string do I need to buy if I want to connect the top of my flagpole to the bottom over here. I want to know this. Okay, I know that where I'm standing right now, I've made sure that the angle over here is 30 degrees from the top. Okay, it's 30 degrees from the top. How am I going to use what we know about trigonometry to calculate for this length? I want this. I want the length here. In meters, please. No, she's not 10 meters tall. She's very short, very short. Lucky, we're going to talk about that. Lucky just asked a question. Lucky says, when the answer is in fractions, does it always have to be in decimals? Lucky, it will depend. Okay, so if we're just looking for ratios, leave it in decimal form. Okay, not in decimal form, sorry, in fraction form. If we're looking for ratios, leave it as a fraction. Okay, but if I'm asking you for a length, nobody's ever going to give me a length in fraction form. Okay, give it to me in decimals. And the question will always say, to the nearest whole number, or to 3 decimal places, or to 2 decimal places. It will always tell you. So in this case, because I'm looking for length, I'm going to leave it in decimal form. All right, so let's look at our mnemonic device, guys. I want saw, I've got saw, ka, toa. Tell me in the chat, what information do I have? What have they given me? In relation to my angle, what information have they given me? Michael already says TOA, Anela says cos. I'm not 100% sure you guys are going to get it unless you give me what I have. Okay, because at the moment, we're guessing. Think about it. What have they given me, guys? Oh, see, guys, remember, we need to make sure we're thinking of the question exactly the way it's been given. What have they given me over here? They've given me an angle. They've given me an angle of 30 degrees. And they've also given me, in relation to my angle, what is this side over here called? In relation to my angle, that side is called my opposite. Good. So they've given me my angle and my opposite. Now, what do I want in relation to my angle? What are we actually looking for? I need to add just a tiny little 90-degree angle over there. That's it, Nkandla. What are we looking for, guys? What do I want? I want my hypotenuse. Good. I want my hypotenuse. So let's think about this again. Between SO, Ha, and TOA, which one of them needs the opposite and the hype? Which one uses op and hype? The opposite and the hypotenuse. Ooh, think about it again, Anele. It's not going to be, aha, there we go. It's going to be SO, because O and H meet my opposite and my hypotenuse. So it's SO. And we know that the S in SO stands for sine. Good. So we're going to go, let me write this in blue, sine of the angle theta is equal to my opposite over my hypotenuse. Okay, but now they've given me my angle, right? So I'm going to go sine of 30 degrees is equal to, my opposite side is 10 meters over my hypotenuse, right? Now, this is looking a little funky in that the thing that I want is actually at the bottom, and that's not very helpful. Okay, it's not very helpful. So what I'm going to do, guys, is I'm going to multiply both sides by h. Multiply both sides by h. Okay, so what's going to happen is these two h's will cancel because h divided by h is 1. And then I will have h sine of 30 degrees is equal to 10. Now, I want to isolate h. This h is multiplied to sine of theta. How do I get sine of theta on its own? What do I need to do? If they're multiplied together on this side, how do I get rid of it? How do I take it to the other side of the equal sign? Good. We divide by sine of theta. Good. So we're going to divide by sine of theta on both sides. Sine of theta divided by sine of theta. There we go. And then sine of theta divided by sine of theta will give us 1. Therefore, h is equal to, now, I want you guys to go into your calculator and type into your calculator 10 divided by sine of 30 degrees and give me an answer, please. What answer do we get? And Dando says 30, I mean 20. I agree with you. That's it. It should be easy because sine of 30 is a half of, oh, 10 divided by half is indeed 20. So my height, the length of this part over here, my hypotenuse, the length of my rope is going to be 20 meters. Now, it's important that you write 20 meters because they've given us a unit of measurement. So do not forget to write in there 20 meters. All right. Can I give me any emojis, guys? A thumbs up, a thumbs down. How are we feeling about the idea of angles of elevation? Remember now what we've done over here. This is an angle of elevation. This is elevation because we're looking at it from bottom to top. Okay, I've got a couple of thumbs up. Loving it, guys. Awesome. Okay, Kulukhalu says, no, ma'am, it's a no for me. Unami says the same. That's okay. We're going to go through a couple of examples, more examples, and we're going to try and interpret them. Remember, angles of elevation and depression are always told in some sort of form of a story. Okay, so we're going to try and understand the story and what they want from us, just so that we can kind of get the idea of what's happening. Okay. All right. Okay, I'm getting quite a few thumbs up. Those with thumbs down, I want you to really stay with me. We're going to go through another example quickly. All right, let's read this. Okay. This question over here says, from an airplane at an altitude of 1,200 meters. Now, let's think about this. Our airplane is not going to be on the ground, right? Our airplane is not going to be on the ground. This is the ground over here. And our plane is going to be where? In the air at an altitude of 1,200 meters. Now, what that tells us is that from where the plane is, guys, do not laugh at my plane, I beg. Okay, I tried, really, I tried. There's my airplane, okay. Okay, so this is the ground over here. Okay, that is the ground, and that's my airplane. And now it says that my airplane is at an altitude. Michael, I know. Okay, my airplane is at an altitude of 1,200 meters. Now, what that tells me is my airplane in relation to the ground is at 1,200 meters. Okay, that's how far up it is. Okay, now it says the angle of depression to a building on the ground measures 28 degrees. So what this actually means is there's a tiny building over here, right? And from my little building over here, all the way to, or from my plane to my building, this angle over here is 28 degrees, right? Okay. Let me see if I'm interpreting this question correctly. All right, from an airplane at an altitude of 1,200, the angle of depression to a building. Oh, so I'm lying. So this isn't the ground. This is our building. Our building is over here. This is our building. Okay. Building. This is where our building is, which means that our building is actually on this line. Our building is here. There's our building over here. Okay. And my phone is irritating me, so I'm going to put it on mute. In 1 second, guys. Right. There we go. Okay, I know, Michael, I know it looks like a rocket. All right, so it says here that the angle of depression is 28 degrees. And then it says, find the distance from the plane to the building. Okay, now, guys, let's think about the information we've been given. Okay, let's think about the information we've been given. What I know for a fact is that if I have my altitude over here, and this is my building over here, what do I know about this angle over here? What is this angle over here, guys? Think about everything we know about angles. What do we know? Anybody? Somebody? How much is this angle over here? That's it. Lihle, you're 100% correct. Okay, it's going to be 28 degrees. Nolwazi, why is everybody saying 28 degrees? Because of Lihle's reason, because of alternate angles. Alt angles. So this one is also going to be 28 degrees. And our reason over here is alt angles. Okay, it's going to be alternate angles. All right, now, do we see what we have? Oh, okay. So remember, Nolwazi, in grade 7, we did this. You did corresponding angles, and then we did co-interior angles, and then we did alternate angles. Do you remember that? Fun angles, that's it. Yes, yes, Mohammed. That's it. We did fun angles, and this is it. Okay, so the one that we're using over here, the one that we're leveraging is called alternate angles. Okay, and if we do not remember alternate angles, we need to go back to grade 7 and grade 8 maths. Okay, these are called co-interior, and these are called corresponding. Okay, this is something we did in grade 7. And guys, can you believe something you learned in grade 7 is there in grade 10? Oh, we need to pay attention everywhere in maths, ma'am. We need to pay attention all the time. Okay, you see that? See that? All right, now let's think about the information that we've been given. What do we have, guys? Tell me, what information do I have and what do I want? Let's think about this. Okay, remember, they want the distance from the plane to the building. So they want distance. They want this distance. Good. Good. You see, Likoto, excellent. You're doing the right thing. You guys are saying the right thing here. They've given us our opposite, right? And they've also given us our angle. Thank you very much. Our angle is 28 degrees. That's it, Funzo. What do we want, guys? What do we want in this case? Have a look at what they've given us. Tell me what we want. Okay. We want the hypotenuse. That's it. We want the hypotenuse. Excellent. And teacher Kat makes a valid point. The angle of depression is always measured from a horizontal line, which is parallel. Okay. So what we're actually saying in this case, Nolwazi, is that this line over here is parallel to this line over here on the ground. Okay. Good. Okay. Excellent. Guys, I'm going to ask you again, between the saw, the car, and the tower, which one are we going to use? Unati, you need to read the comments. They're very important. That's it, Una. That's it. Unako. Oh, sorry, it's Unako, and I'm saying Uno. Okay, yes, Unako. That's it. We're going to use saw. And we know that saw is sine. So we're going to go sine of, I'm not going to waste any time. I know that sine of my angle, 28 degrees, is equal to my opposite. In this case, my opposite is 1,200 divided by my hypotenuse. Now, let's look at what we've got. I just want to move things around so they're not so in one place. 1,200 meters. All right, who can remind me, what is the next step? What are we going to do next? That's it, Mohammed. You've got it. Good. Well, our next step is going to be to multiply both sides by h. We're going to multiply the side by h, multiply by h, because we're trying to isolate h, and we don't like the fact that h is in the denominator. So h divided by h will give us 1. So what I will have left is h times sine of 28 degrees is equal to 1,200. What is my next step, guys? My next step is third. Okay, good. All right, you guys are getting it. Excellent. We're going to divide. Good. We're going to divide. That's it, Kimoko. We're going to divide by sine 28 on each side. Sine 28. And you see how Lihle has already got an answer for us, because when you understand the maths, it's so much easier to do. So we're going to punch that into our calculator. Therefore, h, our height from the airplane to the top of the building is. Liche's got an answer. I want to see if everybody else agrees with Liche. Everybody grab your calculator. Do what you got to do. I want to see if everybody agrees with her or him. I'm not sure if it's a her or him or a they. Okay. Basitana agrees with you. Excellent. Jonathan agrees with us as well. So does Kimototro and Litotro. All right, excellent. I agree with you guys. My calculator says the same thing. Our height is going to be 2,556,06 meters, because we're calculating in meters. All right, okay. I think we're getting a hang of this. All right. We should. Ooh, 0.07. Thank you, Teacher Kat. Sorry, yes, you actually, guys, we all failed. We all failed. 0.07. Yes, that's it anyway. The rest of us got it wrong. It's 0.07. Guys, we're supposed to round properly. How could we miss this? Okay, I missed it. I missed it. Thank you, Teacher Kat, and everybody who got it correct. Yes, Mohammed, you did. Mohammed got it right. Litotro got it right. Jonathan got it right. It was me who did the wrong things. Okay, yes, you did, guys. You did. All right. Excellent, guys. Okay, let's look at this next question. I want you guys to theorize what's going to happen here. If there's any brave soul who would like to unmute and have a conversation with me about this one and what we're going to do, would love to hear from you guys. Okay, so this one says, from a top of the ground, 12 meters from the base of the flagpole, the angle of elevation to the top of the pole measures 53 degrees. How tall is the flagpole? Ooh. Okay. Anybody got any ideas? Okay, first thing we're going to do, obviously, is we're going to try and draw this. Make sure that we're drawing it correctly so we're not making a mistake. Now they say here, from a point on the ground. So we're going to make a point on the ground. Point. Okay. 12 meters from the base. So if this is the base of our flagpole, this is the base of our flagpole, like that. If this distance from here to there is 12 meters, right? And the angle of elevation from the top of the flagpole, to our point measures 53 degrees. So this measures 53 degrees. They want to know how tall is the flagpole. So how tall are you? All right. Don't forget our mnemonic device, guys. So, Toa, tell me, guys, what are we doing? What do we have? And what do we want? What do we have, guys? Good, Mohammed. We've got 53 degrees, and we've got, in relation to our angle, yes, Anele, that's it, Funzo. In relation to our angle, we've got the adjacent side, the side right next to my angle. This one, this is my adjacent side. Okay, good. So I've got my 53 degrees and I've got my adjacent. What do I want? Tell me, what do I want? That's it. I feel like Funzo already had that typed and she was just waiting for me to say, what do I want? And then she went, send, yes. Good, we want the opposite side. Okay, good. There we go. So now let's have a look at our mnemonic device between the saw, the car, and the toa. What are we going to use, guys? Saw, car, or toa? Which one has adjacent and opposite? Saw, car, toa, which one? Yes, that's it, Unako. That's it. We're using the toa. That's it. Okay, we're getting it. We're getting it. I told you guys, this is easy stuff. This is easy stuff. Good. Okay, so I'm not going to waste any time. I'm going to go tan of our angle, tan of 53 degrees is equal to, the opposite is the thing that I want. I don't know what my flagpole is, so I'm going to call it opposite, over my adjacent side, which is 12. My next step. What is my next step, guys? What is my next step? The division, that bottom part is always the part that I don't want. Good. I'm going to times by 12 on both sides. Let's multiply by 12. I'm always trying to get rid of the denominator. 12 divided by 12 is 1. Therefore, the opposite is equal to the tan. Ooh, let me not lie to you guys. 12 times. 12 times the tan of 53 degrees. Okay. Punch it into your calculator, guys, and let me know. Therefore, opposite is equal to. How tall is my flagpole? Ntageni said you got a little confused. All right, Ntageni, I need you to type me in the chat, where did I lose you? Tell me exactly where I lost you. Okay. Oh, but you understand. Okay, that's fine. That's excellent. All right, for those of you saying 15,92, be careful. Round properly again. Think about it. I've got 15,924,537, and it goes on and on and on. If we're going to round off to 2 decimals, guys, what's going to happen? My 5 is going to change this 4 into a 5, and this 5 is going to change this 2 into a 3. So my answer should be 15,93. And Mohammed, I don't know where we got 86 from. We need to think about that. We really need to think about where the 86 came from. I'm not sure. All right, so we're going to get 15,93. All right. Excellent. Meters. Don't forget it's in meters. All right. Okay. I'm going to ask again. For those of you, that's okay. For those of you who were a little confused, and for those of you who are still with me, give me a thumbs up if you understand everything that's happened. Give me a thumbs down if you're still a little confused. At this point, I'm hoping everybody's 100% with me, because if we just follow the steps, guys, what do I have? What do I want? What does the question say? Okay, we just need to be able to interpret it. Okay, excellent. I'm getting a lot of thumbs up. Loving it. Awesome stuff. All right, so let's go ahead and have a look at an exam question. All right, so this question that we're about to look at comes straight out of an exam paper. Okay, a grade 10 exam paper. I want us, okay, Unako, I'm going to do that in a second. I want us to recalibrate and think about what exactly is happening over here. I'm gonna quickly just go back over here. Okay, please re-explain the part where we times by 12. Okay, Unako, have a look here. I want the opposite by itself. I want the opposite all by itself. And the problem over here is that I've got opposite divided by 12. Now, how am I going to get rid of divide by 12, Unako? I'm going to have to times by 12, because 12 divided by 12 is going to give me 1, and then the opposite will stay on its own. Okay, so I have to multiply by 12 on this side. But what I do on the right-hand side, I also have to do on the right-hand side. Okay. Okay, excellent. Unako's with me. All right. I want you guys to give this question a read. Make sure you're 100% understanding what's happening. Sorry, I've got a lightning alarm going on off outside my door, which means I'm not allowed to leave my house because there's a lightning storm right outside. So hopefully it will stop in a second. All right, let's read the question quickly. It says, in the diagram below, AD is equal to 13 units, AB is equal to 12 units, and DC is equal to 3 units. And then it says DBA, and normally, guys, when it says DBA, whatever the one question that has a little copy on the top, that's the angle that they're talking about, the one right in between. So if we follow DBA, we're going to look for DB, where's A? A is over there. So the angle that they're actually telling us about is this one, right in the middle, that one. DBA and DCB. So we're going to start at D, and we're going to go to C, and we're going to go to B. There we go. That's the angle they want from us. Are two right angles in a quadrilateral, A, B, C, D. So we've got a quadrilateral, A, B, C, D. Okay, that's it, Mohammed. They're both 90-degree angles. So they do tell us in this. Okay, and guys, I'm going to tell you now, if you come across a question like this, where they give you all of this information at the beginning, read it. Okay, read it. Okay. Read it. Yeah. The reason why I want you guys to read it is because sometimes they give you a drawing and they don't write all the information that you need on the drawing. We're lucky enough that in this particular drawing, they gave us all the information on the drawing. But sometimes what they'll do is they'll leave out the numbers. They'll leave out the numbers. And then they'll give you the information up top here. So you need to go fill it in yourself. But if you don't read that top part that they've given you, you're going to look at this question and you're going to be like, And then the first thing you guys are going to do is you're going to put your hand up in the exam venue, and then your teacher's going to come over and you're going to be like, ma'am, sir, I think they made a mistake. They left out the numbers. And then your teacher's going to look at you and they're going to go, not another one. Why don't they just read it? Okay, we need to read the question. Okay, we do these kinds of things on purpose. So please read. I'm going to ask you guys the question again. I'm going to ask this again. When you are given information up top the diagram, what do we need to do? Please tell me in the chat. What do we need to do with the information atop the diagram? That's it, Unati. We need to We need to read it. Good. Please don't forget this, guys. Read the information. And then when you're reading the information, double check. So they're saying AD is equal to 13. Okay, AD 13 minutes. Okay, good. Then they say AB is equal to 12. Okay, AB is equal to 12. All right. All the information checks out. That's what we're doing. We're making sure that everything says exactly what the top part is telling us to do. Okay, excellent. Now let's look at the first question that they've got here for us. 2.1 says, calculate the length of D. Now let's go find DB. Here's DB. Okay. It says calculate the length of DB and calculate for the length of BC. Anybody got any idea? What are we going to do here? Anybody? Somebody? Yes, that's it, Deborah. Deborah, you've got the right idea. Good. You guys will notice that they haven't given us a single angle. Not a single one. We don't have a single angle. But we do have right-angled triangles. Okay, well, you could say that 90 degrees is an angle. But they haven't given us any of the angles over here that could possibly help us. So the only thing we do actually have that's going to help us here is the sides. So we can use Pythag. We can use a Pythagorean theorem. So I want you guys now, okay, to use the Pythagorean theorem to solve for this, okay? Solve for DB and for BC. Now, the way we measure these things in an exam setting is if this question is worth 4 marks, you've got 4 minutes to complete it, okay? It's a mark a minute. It's a mark a minute. That's the matric standard. So I'm going to give you guys 4 minutes to calculate for DB and to calculate for BC. Now, remember, you can't just write in your book, you can't just go DB or on your answer paper, DB is equal to something, BC is equal to something. You need to go through the steps, guys. You need to start by saying DB squared. Yes, that's it. Oh yeah, your formula is a little off there. Remember, we need to square everything. Okay, so we need to go DB squared plus AB squared is equal to AD squared. And then we need to remember to open brackets and write our reason. We need to write Pythag. Okay, all of this is important. It's very important. We need to do it exactly the way that it's written on the screen because you can't just start pulling out theorems from wherever. You need to tell us what you're doing and where it comes from. Okay, and Unako, though I acknowledge that your answer may be correct, yes. Okay. I still need you to go through the motions. Okay. Anele, what 5 what? What is 5? You need to be very specific. Look at Unako's answer and make sure that we're writing it exactly the way it's written. Okay, because 5 isn't going to mean anything to me. You still need to calculate. Good. You need to calculate for BC for me as well. For those of you who are timing yourselves, you've got 2 minutes left. Yes, yes. Thank you, Teacher Kat. It does, Nati. Thank you. All right. So most of the time, if we're looking for an angle, we'll always use the smaller letters for the angle because these have been capitalized. So make sure that if they're capitalized, you're also using capital letters. Okay. That's it, Ntangeni. That's what I'm looking for. Unati, I see you. You're supposed to be giving me answers. Give me answers. That's it, Inirani. All right, go for it. Good. If you guys have if you guys have DB, go ahead and calculate for BC for me. You've got 1 minute left, everyone. Capital letters, Jonathan, don't forget. Good, Unako. Capital letters, Lihle. All right, I'm going to take everyone's answer on this one. You guys seem to have gotten the correct one. DB is equal to 5. That's it. There we go. I need to get that right. Okay, yes. Excellent, guys. Awesome stuff. Okay, and I agree with you guys. BC is going to equal to 4. And just for good measure, so that I don't get in trouble, I'm going to add units here and here. Units, units. All right. Then what I'm going to do is I'm going to give you 1 mark for accuracy and 1 mark for continuous accuracy. And over here, we would have done the same thing for this one. We would have written DC squared plus BC squared is equal to DB squared. And then you would get 1 mark for accuracy and 1 mark for continuous accuracy. But this over here will have the correct questions. The correct numbers in it. So my DB would then be, DB is what we're looking for. Then I would replace AD with 13 squared. Oh, Nolazi says, please explain how you all calculated BC. Absolutely. So remember, we've just calculated DB, and DB came to 5 units. Now, if you look at our triangle, Nolazi, in this triangle, in the smaller triangle over here, DB then becomes my hypotenuse. This then becomes my hypotenuse for my smaller triangle. And then I can use Pythag again. Okay. And I can use Pythagoras again to find my missing side, which is BC. So I've got 5 and I've got 3, and I can calculate for BC, which would then give us 4 units. That's it. Okay. Kimukuro is 100% correct. Where you get the answer for DB, add that onto your drawing so that you can see it. Okay. Here's DB right there. DB is equal to 5 units. All right. It's easy enough, I think. All right. We're going to do questions 2.2.1 and 2.2.2, and then we're going to call it. Okay. Because we're going to run out of time. All right. So this one over here says, without the use of a calculator, okay, determine the value of the following. Tan of A. Now let's go have a look at A. Here's our angle A over here. This is our angle A. And we know that tan, let's write so toa. Okay, toa. Tan is going to be opposite over adjacent. So we can even write, we can just go tan of A is equal to, how much is my opposite over my adjacent, guys? What is that going to be in fraction form? Because remember, this time I'm looking for a ratio, so I can leave it as a fraction. Okay. Tell me, have a look at my drawing, guys. What is tan of A going to be? Now you have to look at this. What is this side called? What is that side called? What is that side called? That's it, Funzo. Okay. Good. That's it. It's going to give me 5 over 12 because this is my adjacent side over here. Adjacent, and this is my opposite side over here. My tan of A will be equal to 5 over 12. Okay, and because they said without the use of a calculator, I'm not going to be able to figure out what 5 over 12 is as a decimal. You're going to get the mark for leaving it like that as a ratio. Okay, then they want us to find the sec of ADB plus the sine of DBC. Now there's some work to be done. Now we need to remember our cousins. We need to remember the reciprocals, right? So for sine, we had cosec, which is equal to hypotenuse over opposite. For cos, we had sec, which is equal to hypotenuse over adjacent. And for tan, we had cot, okay, cot, which was equal to adjacent over opposite. Now, these are the cousins. If you don't know who the cousins are, you need to go watch the video where we talked about the cousins, who are the reciprocals of SOCA and okay, or the reciprocals of sine, cos, and tan. All right, so when we're looking for sec, guys, when we're looking for sec, we're going to be using this one over here. This is sec, and sec is equal to hypotenuse over adjacent, but they want the sec of the angle D. So let's go find D in ADB. So this is going to be this one over here. This is my angle over here, D. That's it. That's the ones we're looking for, Unati. All right. So if we look at our D, our angle, what is the hypotenuse and what is the adjacent to D? Guys, have a look. Because I'm looking for hypotenuse over adjacent. What is my hypotenuse? My hypotenuse over here would be 13. Good. That's it, Muhammad. And my adjacent side would be my 5 over here. So the sec of ADB is going to equal to 13 over 5 plus, then we need to go look. They want the sine of DBC. Now we need to go look. DBC. So DBC, this is the angle they want, and they want the sine. So my sine is normal. Sine is going to be opposite over hypotenuse. So we're going to do, what is my opposite, guys, and what is my hypotenuse? Tell me. What are we looking at over here? Good, Deboho. My opposite is 3, and my hypotenuse in this case is going to be, oh, Muhammad is using the wrong triangle. You need to use the correct triangle, because this is our angle over here, and they want it in this tiny triangle over here. Good. And the hypotenuse is going to be 5. Excellent. So this is going to be 3 over my hypotenuse, which is 5. And then what we can do over here is we just need to add our 2 fractions. Now they have the same denominator, so I'm just going to add the top. This is going to be equal to 13 plus 3, which is 16 over 5. Okay.